In this video and section, we're going to talk about matrix algebra. Now, a matrix is a rectangular array of numbers. Matrices provide an efficient way to solve problems of linear equations and to record data. The tables of data presented are examples of matrices. So here's our definition. Let M and N be positive integers, and the M by N matrix is a rectangular array of M rows and N columns. Now, if you notice here, it says A11, that means entry, first row, first column. A12 would be entry, first row, second column. Entry A21 would be entry in the second row, first column, and so on and so forth. Now, we can also use the shorthand A and then sub I sub j for this matrix. Now, each element or entry A sub ij of the matrix uses double script notation. The row subscript is the first subscript I, and the column subscript is j. The element aij is the ith row and jth column. Now, I understand it's maybe a little different to say that, but that's how we say it. In general, the order of an M by N matrix is M by N. If M does equal N, meaning the number of rows equals the number of columns, the matrix is considered a square matrix. Two matrices are equal matrices if they have the same order and their corresponding elements are equal. So in example 1 here, we need to decide the order of the matrix, indicate whether or not it's square. Well, this has 2 rows and 3 columns. So this would be a 2 by 3, and that's the order. 2 by 3 is not square. Simple enough. Now the order in B, there are 4 rows, 2 columns. So if the order is a 4 by 2, again, this is not square. In letter C, the order would be 3 rows by 3 columns, so this is a square matrix. Now, also in this section, we're also going to add, subtract, multiply by a scalar, and multiply 2 matrices. Now, we add or subtract 2 matrices of the same order, meaning they have to have the same number of rows and the same number of columns, by adding or subtracting their corresponding entries. Matrices of different orders cannot be added or subtracted. So really, we're just going to add the same elements in the same direction. Now, we can also multiply our matrices by a scalar. The product of the real number k and the M by N matrix will be k times that entry. So if we look at example 2a here, we need to find a plus b, a minus b, 3a, and 2a minus 3b. So when we do this for part A, we have a plus b, so we're going to take matrix 2, negative 1, 3, 5, plus 1, negative 2, negative 3, negative 4. Now, I really don't know how much matrix mathematics you've done, but it's actually really simple. So we're going to take 2, since these are both the same order, a 2 by 2 and a 2 by 2, we can add them. We're going to take 2 plus 1, which is 3, 3 plus negative 3, which is 0, negative 1 plus negative 2, which is negative 3, 5 plus negative 4, which is 1. So there's a plus b. For part B, we're going to take a minus b. So we're going to have the same matrices in the same order. And we're actually going to subtract these. So we're going to take 2 minus 1, which is 1. 3 minus negative 3, which turns into 3 plus 3, that's 6. Negative 1 minus negative 2 turns into negative 1 plus 2, which is 1. 5 minus negative 4, which is 9. Now part C says 3a. So we're taking 3 times our matrix, 2, negative 1, 3, 5. That will simplify to 6, negative 3, 9, 15. Now for part D, it says 2a minus 3b. So first things first, we need to find 2a minus 3 times b, and b is 1, negative 2, negative 3, negative 4. So when you solve these and simplify it, we'll have 4, negative 2, 6, 10, minus, we're going to keep it minus here, so it's 3 times 1 is 3, 3 times negative 2 is a negative 6, 3 times negative 3 is negative 9, 3 times negative 4 is negative 12. So when we simplify this, you'll actually get 4 minus 3 is 1, 6 minus negative 9 is 15, negative 2 minus negative 6 would actually be 4, 10 minus negative 12 would be 22. So there you have it for example A. Now in example B, we're going to do pretty much the same thing. So again, we're going to have A, which is A plus B. We're going to add our elements. Negative 3 plus 4 is 1. 1 plus 0 is 1. 0 plus negative 2 is negative 2. Negative 1 plus 1 is 0. 2 plus negative 3 is negative 1. 1 plus negative 1 is 0. Now for part B, it says A minus B. Negative 3 minus 4 is negative 7. 1 minus 0 is 1. 0 minus negative 2 is a positive 2. Negative 1 minus 1 is a negative 2. 2 minus negative 3 is 5. 1 minus negative 1 is 2. Now for part C, we want to find 3a. That will actually give us negative 9, 3, 0, negative 3, 6, 3. Makes it nice and easy. Now for part D, it's 3a minus 2b. Change it back, it's 2a minus 3b. So 2 times a minus 3 times b. So when you simplify these, you'll actually get negative 6, 0, 4, 2, negative 2, 2, minus 3 times this matrix, so 12, negative 6, negative 9, 0, 3, negative 3. Simplifying further, negative 6 minus 12 is a negative 18. 2 minus 0 is 2. 0 minus negative 6 is a positive 6. negative 2 minus 3 is a negative 5. 4 minus negative 9 is 13. 2 minus negative 3 is 5. So there's your answer. Now in the next video, we're actually going to multiply these matrices and do some applications with it.